All right. Good morning there, students. Glad to see you all about.
Good morning.
We're halfway done. Halfway done. And everybody looks like
Good morning.
y'all are hanging in there. All right. Anybody got any questions? Let me just share the screen and show you what we're working on. All right. So we keep taking up now the rest of the probability chapter. All right. So in probability, they show you those counting methods, and then they'll introduce you to basic probability, which is what we did. And now we're going to get about 4 probability rules and then a couple of other little things. And the way this system handles it, it's a little bit, they seem to be heavy on the conditional probability. So, but that's not a problem because usually it doesn't, we don't usually cover it until the last, but this way you won't have to, you'll get it right away and have time to get used to it. But I went through the first probability rules homework, and it was like started with conditional probability. And like I said, I usually hit probability. I'm sorry, conditional probability last, just because it's usually the most, the hardest one. But they stick it in there first, and then they keep mentioning it throughout. So, um, what I'm going to do today, I'm going to give you a little tour of the chapter of probability. All right. So one of the things that they use in probability is you can use a a diagram or such thing to kind of see what your possibilities are, and then more easily establish the probability. Because remember, probability is always just total in the denominator, and the numerator is the number of occurrences of a particular event. Okay. So remember we talked about this little tree diagram with the couch. You can have 2 finishes, the leather or the microsuede, and then 4 colors. So that gives us 8 different choices. All right. And then we can extend it. So this is the use of the counting principle. And let's just say we wanted to find out of this scenario, which has got 8 times 2, that it's got, so there's 16. So let's say we want to find the probability. So this is the way we do this. So probability of green. We're just going to say green. So that's a green couch. So what would be the probability of green? Well, first of all, we need to know how many of them. How many are there? And we're looking at this one here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's the 8 times 2. 2 times 4 times 2. So our total is 16. And then how many are green? Well, there's 2 of them. You can either have it, I'm sorry, there's 4 of them. So 2 here and 2 here, so that's 4. So 1/4. The probability of that getting that green couch is 1/4. So that's simply using the counting principle with probability. All right, let's see if we can find something else to get into. All right. And there should be a little assignment in there for you to do. I think I got it started 11:15, 11:30 or something. I'm not sure. I forgot. All right. Let's see if we can find some at the back here. Where are the darn problems in it? Get back up here. Oh, it says it's failed to load. I know why, because this thing is an old one. Let me open it up fresh. That was still open from the other day. All right. All right, so where's that book at? All right, so here's some of the kind of ones that'll be in that little assignment. But all right, let me find a good one. Okay. So here's a kind of a situation, and it does help to have a tree diagram on these. And let's see, three. Let's see if I can fit one in here. 3 computers are chosen at random from an inventory of Dell and Acer computers for a bookstore display. So it works like this. You only got 2 choices, Dell or Acer. So we're making a tree, and it gives us all the choices. And I'm going to label things in a second to make it a little bit better. It's really hard to draw out a diagram for anything of substance, but here's the way we're going to do it. So this would be Dell and Acer. So this is the first one. Okay, first. There's that one choice. The second computer then also has the choice of Dell and Acer. Same thing here, Dell, Acer, Dell, Acer. The same thing's going to happen down here, Dell, Acer, Dell, Acer, Dell, Acer. All right, so then the ones that I have are Dell, 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 Acer, Dell, Acer, Dell, Dell, Acer, Acer. Let me take that little space out. So Acer, Dell, Dell, Acer, Dell, Acer, 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 Dell, Acer, Acer, Acer. All right, we can clump them all together. I was just trying to spread them out so that they were next to the side, next to the path. But this is all we have. Those are the choices that we have for the two computers, because it's a random event on which one is chosen. All right, so this is the sample space. Now we've got 8 of these. 1, 2, 3, 4, 5, 6, 7, and 8. They're all unique. These are what we call the permutations. They're all unique. All right. Now, what would be the probability that we're given three Acers in our display? All right. Well, there's how many total computers? Always look at your denominator first. That'll ease your mind if you can do that. All right. Now, how many are all 3 Acers? Well, there's only one of those. So the probability then of all 3 Acers is 1/8. Okay. Exactly 2 Dells. Exactly 2 Dells. Well, this one's not because that's got 3, but this one does. Dad's got 2 of them. Nope, that's just 1. 2 deltas. I'm sorry, Dells. 1, so that's not it. So out of these, the probability of Dell, we're just going to say, we don't care about the third one. We know it'll be an 8th, sir, but there's going to be how many of those? Well, there's 3. Essentially what there is, and I can kind of do it. Let's see here. It'd be Dell, Acer, Dell, Acer, Dell, Acer, Acer. Whoop. The DAD one, and then ADD. So for that, there's 3 over 8. 3 over 8. All right, and then the last one, at least 2. Well, what does at least 2 mean? At least 2. Got to make sure you're thinking about that, right? Because let's use a different color there. So at least 2. In other words, 1 Acer is not enough. So, but as long as there's at least two, which means two or more, all right. So definitely not the top one, because that's no acers. No acers. I was going to use a different color here. All right. So this one's got two, only one acer. This has only got one. But now we're talking here. We got two, two, and two. All the rest of these, this one and that one, only have one. Oh. That one is two. Okay, I should have done that one. So two acers, two acers, two acers, three acers, all of those at least one. So then that's four. So let me write that out here. Greater than acer greater than two. Put that there. Well, they're going to have four of them. We've got them marked with our gold star. And there's total of 8. So the probability of at least 2 is 1/2. All right. All right, this is a good one here. Now, let me see if I can do something here. Let me see if I can find a template on here I can use. I don't have to draw the darn thing every time. It's got to be 3. Three choices of 2. All right, here we go. There's really only several possibilities for the more usable truth tables, because if you got two choices 3 times, it's 2 times 2 times 2. And I was trying to find it when it was already made, but I'm just going to go ahead and make one. I'm trying to make a better one. All right. So each of these would work with something like flipping a coin, head or tail, boy or girl with children, anything where there's only 2 choices, and yet you're doing something 3 times. In other words, let's see. Let me go back over there and get that problem. All right. So what we got here, and this is a simple pool game where these two guys are playing 3 games of pool, and each time they play, we're going to have one win. Okay? Don't have to worry about probability. It says equal ability, so it's just a matter of probability whether they're going to win or not. Okay? So this would be Mark and Raul. And this would be game 1. I'm going to just abbreviate it as a G1. G2 would be game 2. And then game 3. Now, in each one of the games, we can have only one winner, Mark or Raul. Mark or Raul. Mark or Raul. Same thing all the way down. And then that's going to be very similar to what we were just doing here. Okay, so again, we got 8 choices on how this game can, these 3 games can come out. All 3 of them could go to Raul. I'm sorry, Mark. All 3 of them could go to Raul down here, or we could split with 2 Marks and 1 Raul. Or we have it with 2 Rauls and 1 Mark. There's several different options. So let's see if we can answer these questions. All right. So draw a tree diagram to determine the sample space. So that's done. Now, question 1 is either Mark or Raul win 3 games. Well, there's only one possibility for each one to win 3 games. All right. So one of each, and it's or. So the probability of 3 games is equal to 2 over 8. And so that's equal to 1/4. 2 out of 3. It doesn't care which one. It says either Mark or Raul. So 3 games. I'm sorry, 2 games. 2 out of 3. So that would be this one, this one, this one, this one, this one, and this one. It's really just all of the other games, because if you got an odd number of games, somebody's going to have 2 and somebody's going to have 1. So then this is 2 games is equal to, and it was 6 over 8. All right. Mark wins only 2 games in a row, meaning not 3 games. Okay. Not 3 games, but only 2 in a row. All right. Only 2 in a row. 2 M's we're looking for. 2 M's. in a row. There's one. Here's one. All of the other ones are Raul having 2 games.
And it's the MRM one, right? The third one.
What's that?
Would it be the MRM or it's because it's in a row?
It says in a row. They got to be in a row.
Okay.
So it's got to be 2 M's. And it's only 2 games in a row, not the top one.
Because the
All right, because that
one
one's
is
3 games.
MRM.
Yeah, MMR, MRM does not count because they're not in a row. These are in a row. MM,
Gotcha.
not. So I'm just going to put M2 for 2 in a row for Mark. Eight, and then 2. So that's 1/4. So here we want Raul first game, loses the second game, meaning that Mark will take it and wins the third game. How many are there in that order? There's only one of them. So 1/8. All right, let me try one more. I'll see how you're doing with your little assignment. I want to do one that's got something other than just 222. I know there's another one. I tell you what, I got one in my notes that I like. I think it'd be better to do.
Excuse me, Professor Cruz.
Yes.
Is that assignment still going to begin at 11:30 or so?
What assignment? Oh, it's
And
not there yet?
um, I couldn't remember the time you told me. Should I be doing it now while you talk, or?
I was going to do one more problem and then I was going to set you free to do on it and then I was going to go over them.
Okay, thank you. I'm sorry.
Yeah, it's
Let's
in
see.
there.
It's there now? I forgot what it's called.
Yeah, it's like in class assignment 1 and it's due today.
Okay. All right. Yeah, that's it. All right. Let's just see if we can look at time to look at another one. Oh, I was going to look at one of the notes. That's right. All right. Here we go. So this is a good one. All right. So this is a tree diagram showing the sample space for flipping a coin and then rolling a die. All right. So now with this one, we got 2 choices for the coin, head or tail. And then we're flipping rolling the die, and then we've got 6 choices. So we got H1, H2, H3, H4, H5, and H6, and then the same thing we're going to do with the tails. If we roll a tail on the, flip a tail on the coin, then we can still roll the die and get 1 through 6. All right. So let's see if we can answer these. Y'all help me. Find the probability of getting a tail, then an even number, tail, and then even.
Would it be 3 out of 12?
So T2, right? T4 is tail and even, and T6. So yes, it would be probability of tail even is equal to 3. And how many total are there?
12.
Remember, there's not always 8. It's just that there's a lot of examples with 8. This one has 12. See, 6, 7, 8, 9, 10, 11, 12. And then simplify. And then this one is just wants to know odd number. So that would be it doesn't say anything about the coin. It's just talking about the odd number. So it's 1, 3, 5, 1, 3, and 5. All of those have an odd number. So the probability of odd is equal to 6 over 12, which is 1/2. Okay. All right. So you should be able to get in there and work on it. If you got any questions, shoot them to me so I can help. If you got questions, okay? They're all based upon the kind of thing I just did. Just looking at the diagram, you may have to draw one. Oh, and let me know if the time is all right. I can't remember what I put. I just wanted to give you like a half hour, but I might if I started it late, it might not give you everything. So let me know. I think I can change that.
It has to be turned in by 11:45.
All right, I can give you a little bit more time on that.
Thank you.
All right, it should be good for the whole thing. But like I said, if in about 15 minutes, I'll go through them if nobody's asked anything. So if I remember correctly, there's one like this or something very similar in the one of those problems, and then the other one about the Dell thing, and then the other one is about the Mark and Raul. So I kind of went to go over three
Yes.
that I knew were in there, and both of the Mark Raul one and the one with the Dell Acer, the tree is exactly the same. The only thing that's different is the labeling, because you got two choices for winners when you're talking about Mark and Raul, just like you got two choices for computers, Dell and Acer. And each time there's three games or three computers that are going to be on display. And it would be the same thing if we did a family's going to have three children, because each choice, each time they have a child, it's going to be boy, girl, boy, girl. Same thing with a coin flip.
Okay.
if you can throw if you can derive the outcomes without drawing the tree, more power to us. I just used it because I remembered it from when we did it earlier. It was the same one that I drew out. So there's our 8 choices. All right. So there's only one of those. So this is a 1/8. Exactly 2 will be acers. So only 2 of those. 2/8 simplifies to 1/4. Now you got to get this right in our head. Before we said at least 2 2 of something. So that means 2 or more. Okay. At most 1 acer now. Now we're looking at the opposite. All right. At most 1 acer. Well, if we look for ones that's just got 1, it would be this one and that one. All right. But do we include anything else with it most? What about 0 acers? Is that at most 1? Yeah. So then again, there's 3 8s here. Okay. All right. Any questions about that one? Let's see what's on the second one. All right. This one's got a thing drew out for us. It's very similar to the one that I just showed you with the coin flip and then the toss of the die. Except now we've got a coin is flipped, and then we got this funny 10-sided die. So instead of 6 sides, it's got 10 sides. So what does that mean? Well, it means then we got 10 that match up with heads, and then 10 that match up with tails. So there are 20 outcomes, which will be our denominator. There was a tail on the coin and an odd number on the die. 1, 2, 3, 4, 5. 5 over 20 will be 1/4. There was a head on the coin and a prime number. Remember, a prime number is it only has itself or 1 as a factor. So 2 and 3 are considered prime numbers, as also 7, and that's it. 5 is prime. That's right, because it's divisible by 5 and 1. 1 is not divisible by any other number than itself, so it's got to have the two factors of prime itself and 1. 2 is divisible only by 2 and 1. 3 is only divisible by 3 and 1. 4 is divisible by 2 as well as 4 and 1, so that's why that one doesn't count. 5, only factors it has is itself and 1. 6, it has 2, 3, and 6 as well as 1, so not that one. 8 is also divisible by 4 and 2, so not that one. 9 is divisible by 3 as well as 9 and 1. Same thing here. This is divisible by 2, 5, and 1, so not that. So it's only these. So probability of prime and head, there's only 3 of those. 4. One-fifth. There was a tail on a coin and a number less than 2 on the die. So we're looking only at the right side. There's a tail on a coin and a number less than 2. Well, there's only one of those on it. Because all of these have tails on the coin, but 2 is not less than 2. 3 is not less than 2. 4 is less than 2. The only one that's less than 2 is 1. So this is 1 over 20. 1 over 20. All right. Any questions? Let's see what the third one can get, what it's like. This is that Mark and Raoul thing. And the reason why I can rattle out the sample space is just because I've just done this when I did the Mark and Roll thing. So remember, we can have all 3 games going by Mark, Raoul, Mark, Raoul, Mark, and then Mark, Raoul. So there's the half of them that would be where Mark wins the first one, and then whatever else he wins. All right, and then let's see, it's so R, and then it's R, M, R, and then R, M. So there's our 8. So there's the sample space. That's what they want in here. MM, 1, 2, 3. One of the numbers. It's not numbers. I don't want to have to draw this thing again. MMR, MMM, MMR, MRM. Oh, wait a second. Okay.
MRR, yeah.
Yeah, thanks. So don't take the risk of. So this right here should be MRR. Don't take the risk and just assume that you know it. All right, so then over here, whoop, it's going to be, because we got the same one twice. There we go. All right. Find the probability that either marker wins all 3 games. There's only 2 of those where they all 3 win. 2 over 8, which is 1/4. Probably the probability that Mark, that one or the other, wins 1 of the 3 games. So we want, and I think that's almost all of them. Let's just double check. So Mark or Raul wins 1 game. So this one, Raul wins 1. Raul wins 1. Raul wins 1. All right, now let's go back and do the Mark ones. Mark wins 3, so not that one. But here, Mark wins 1. Here, Mark wins 1. And here, Mark wins 1. So again, it's very similar to what we answered before. It's the 6 over 8. All right. Which simplifies to 3/4. All right. That Mark loses only 2 games in a row. This looks like the exact same one I did before, isn't it? All right. I don't want to get the whole thing. That Mark loses only 2 games in a row. 2 games in a row. So we got to look for 2 M's. It says only 2, so it would include this one. And that's the only ones. That's the ones that he wins 2 in a row.
He loses 2 in a row, right? So
Oh
it'd be
well, yeah. I'll go
RR.
back up. I was doing. Yeah, good point. So I need to have 2 R's in a row. Yeah. So that one and that one. So there's still only 2. It's kind of the flip side. A lot of these things are symmetric. So there's only 2 where Mark loses 2 in a row and only 2 where Mark wins 2 in a row. So then this is 2 over 8, which is 1/4. Find the probability that Raul wins the first game, loses the second game, and wins the third game. So that's simply going to be, we're going to look for one instance. So that's the probability of Raul, Mark, Raul. All right. And there's only going to be one of those. And right here. So that's 1 over 8. Okay, good. All right, so this one gives us sample space. What this is, it's rolling 2 die. And when you roll 2 die, you get 36 outcomes. If you just roll 1 die, you got 6. But by the counting principle, if you roll one that's got 6 sides and another one that's got 6 sides, there's going to be 6 times 6 or 36 different outcomes. And you can see them all here. All right. 1 1, 1 2, 1 3, 1 4, 1 5 through 1 6. Then match up the 2s for the first one, and all the other ones change. The 3's the first one, all the other ones change. Same thing for 4, 5, and 6. So 36 different outcomes. All right. Now, these are asking for sums. So we want to find on this one the sum of 3. So that means that the 2 numbers on the die need to add up to 3. So this one does it. This one does it. So 1 plus 2 is 3. 2 plus 1 is 3. This one's not, because that's 2. 1 plus 1. Over here, we got 1 plus 3 is 4. This one would be 5, 6, 7. 4, 5, 6, 7, and 8, and so forth. So there's not going to be any more 2s, because as you go down, you're going to just get larger. See here? 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, and 10, and so forth. So for this first one here, there's going to be, I'll write it right here, 2 out of 36. Simplifies to 1 over 18. And that's what's going to go in here. All right, the probability that Rosie rolled a sum that is prime. Again, prime numbers are a little bit hard to identify. Let's write them all out here. We only need to go through 12. So 2, 3, 5, 7, and 11 are the only prime numbers that are less than 12, because all the sums here are going to be 12 or less.
Can you go over what's the easiest way to remember the prime numbers? Because I see that.
You just got to make sure that they don't divide by anything other than themselves and 1.
Okay.
Because if we go through, 1 is only divisible by 1. So we leave out 1. 2 has only 1 and itself as the factor. Same thing with 3. It's only divisible by 1 and 3. But when we get to 4, we have what's called a composite number. In other words, it has other factors, not just 1 and 4 like all numbers would have. And 1, of course, has only got one factor itself. So 4 is also divisible by 2, so we don't do that one. 5 is prime because it's only divisible by 1 and 5. Same thing with 7. 6 and 8, 6 doesn't, because it's got factors of 2 and 3. 7 is prime. 8 is composite, not prime. 9, same thing, divisible by 3. And then 10 is also divisible by 2 and 5. And then 11. So now we're just going to find all the ones that are that add up to 2, 3, 5. Let's see. What was it? It's prime,
So,
right?
Mr. Cruz, my question have the probability that Rosie rolls a sum of 7.
Well, then you pick those.
Yeah.
See, like for 7, you come over here. There's a line, if you notice it.
Mm-hmm.
See, look, 5. Look at this line here. See all of these here? Oop. Those are all sums of 7. That one's that goes that line goes through.
Mm-hmm.
So if you notice that pattern, it will help you if you see these again. All right. So for this one, there's only let's see if we can check them real quick. All right. So the ones that add up to 2, so that would be this one, this one, this one. 4, 4, 4, 5, 5, 5, 5. Those are all prime. So these are the 6. 6 is not prime, but the 7s are. And then 11s here and here. So how many is that? So there's 36. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to double check those because this is not a typical one. So 1 and 1 is 2, 2 and 1 is 3. So both of these. Skip the 4s, go to the 5s. 4, 5, 6, 7. Then we skip to the 7s. 8, 9, 10, 11, 12, 13. And then that's all the 7s. None, the 9s, the 10 don't. So it's 15. So 3 goes into there 5 times. And 3 goes into 36 12 times. All right. So a 3 on 1 or both. Let's see. The probability that roll a 3 on 1 or both dice. 3 or 1 on both dice. So we're looking for anything that's got a 3 or the 1 on it. 3 or 1. And it doesn't say sum. It just says a 3 on one. We're looking for a 3 on one or the other.
Okay.
So this one's got a 3. 3. So this whole line, and then there's going to be 1, and then this whole column. Is there anything else? I think that's it. And then this one in the middle's got both. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? You don't want to count that one twice. So then let's see, that's 11 over 36. So sum greater than or equal to 11. So there's only a couple of those. There's actually only one of those. So this is your 11 line, these two. And it says more than 11. So there's only one of those. Oh, I'm sorry, greater than or equal to 11. So there's 3 of them. 1, 2, 3. Greater than 11, this is 12, and those 2. So it's 3 over 36, which is 1/12. One on one die and 4 on the other. 1 on one die and 4 on the other. All right, 1 on one die and 4 on the other. I think there's only 2 of them, right? 1, 2. So 2 over 36 or 1/18. All right, so that's enough for today. I'll see you back in a few minutes. If you got any questions, stick around.
What about the test?
What's that?
What about the test?
What test?
The exam.
Hold on a second. All right, who was that was asking?
Shakina.
Was that you, Leanza?
No.
Shakina.
Oh, okay. Hold on. Hold on.
Okay.
All right. So does anybody need anything? I do want to talk to Shakina a bit, but I want to see if there's anybody else that needs anything.
Can you give me a few more minutes on the last one?
Well, you got 5 more minutes. You want? Let's see
Okay,
if I
thank
can.
you. Yeah,
You still got 5 minutes. Is that
I
enough?
was still working on the other two. One of the face.
All right. I'll give you a couple more minutes.
Thank
I
you.
also hopped on super late today due to a last minute emergency that just happened.
Mm-hmm.
So for this class assignment, I know I'm not, I got to catch up, everything like that. How much does it duck off?
Well, I'm going to drop several of them, so you can kind of get an idea of if you look underneath that participation grade in Canvas, you can kind of see. I don't know if I dropped any yet, but the grades came out pretty good.
Okay. I was trying
But
to
you
do
know, you don't need to get
it.
every one of them because I'm going to drop a couple of them.
Okay. I was a little lost, so I know that it has a time limit. So I was just a little sorry about
All
that.
right. Sometimes I can extend things, and other times I got it into a mess with the exam. It was working fine, and then I did an extension, and it just fell apart. So with that system, but with this one,
If it is possible, I mean, if you allow, I can catch up and then get it done. But if not, then I respect that as well.
all right. Well, I'm just going to put that on it because, like I said, these are technically meant to be done in class, and
Right.
that's what the boss wants us to because it's a participation.
Yeah.
So it's really not that big of a deal as you're making it out to, but since you're being conscientious, I'll help you.
I just like to make sure that I have everything done. I mean, it is what it is. Just emergencies happen, and unfortunately, it was unexpected. So,
Okay.
I'm to ask, but thank you.
But yeah, it just one thing's not going to make a difference, really.
Okay, no problem.
All right, Chantel, you got something?
Yes, I still was trying to figure out the last one. Just give me a few more minutes, please, because I was
Okay,
still
yeah,
working.
I extended it a little bit. All right.
Okay, thank you.
All right. I want to bounce you out, Chantel, because I want to talk to Shakeen, okay?
Okay, thank you.
Please.
Thank you.
I'll Be back in a minute with the 120. You can still work on it without being in here. All right. So Shakina, can you hear me?
Yes, I can hear you.
All right. So after the next class, I'll try to set it up again because I had sent out that message about if you couldn't get in, because I tried to extend it, but it evidently didn't work, to come back at 9:30.
Yeah, I had got
Now
the
I got to
message
go back
late.
in and set it up again. And then if it doesn't work, then I got to come up with a plan B, and I probably won't be able to do it today. Okay.
They'll be fine. Yeah, they'll be fine.
Yeah, well, I don't want to do that because, like I said, we got new stuff coming. You don't want to be stuck on the old stuff. So I'm gonna go ahead and see if I can set it up now for after the next class, and then I'll sit with you because it probably won't
Okay.
take you too long. Because people I did this morning, and all the other people took it, they did it in less than half an hour.
Okay.
So just remember this: next time I might not be able to be as generous with extending it out this late. Okay. So
Okay.
watch
Yeah,
for
I
the
understand.
instructions and stuff. I'll send out an announcement when it comes exam time. All right. I'll see you a little
Okay.
bit later after the
Okay.
next class. All right. Bye.
Okay.